So, we are discussing very important chapter of class 11, that is set and functions. In set and functions, in this chapter, this important topic is sets. So what is set? सेट का अगर शाब्दिक अर्थ जाने तो सेट का मतलब होता है समूह। सेट को हम समुच्चय भी बोलते हैं। सेट जो है इसको हम लोग समूह बोलेंगे, सेट को समुच्चय बोलेंगे। सेट एक तरह की अनेक वस्तुओं का समूह भी है, जैसे नकली दांतों का सेट। कैन यू गेट ए कटलरी सेट फॉर मी? यहाँ पर सेट का अलग अर्थ हो गया। सेट को हम दृश्य बंध भी बोलते हैं। फॉर एग्जाम्पल, द फिल्म हैड मेगा सेट। यहाँ पर इसका शाब्दिक अर्थ कुछ और है। सेट का शाब्दिक अर्थ रख देना भी होता है। सी सेट ए बिग ट्रे डाउन द टेबल। उन्होंने टेबल के नीचे एक बड़ा ट्रे रख दिया। यहाँ पर सेट का कुछ और अर्थ है। सेट को जड़ना भी बोलते हैं। हर नेकलेस वॉज सेट विथ रूबीज। यहाँ पर सेट का कुछ और अर्थ है। सेट मीन्स निश्चित करना। रवि एंड रीता हैव नॉट येट सेट ए डेट ऑफ देयर वेडिंग्स। यहाँ पर सेट का और अर्थ है। सेट का मतलब परिवर्तित करना भी होता है। सी सेट ए न्यू वर्ल्ड रिकॉर्ड फॉर द मैराथन। सेट का मतलब दृढ़ हो जाना भी होता है। द सीमेंट विल टेक सम टाइम टू सेट। सीमेंट को दृढ़ हो जाने में कुछ वक्त लगेगा। सेट का मतलब कठोर हो जाना भी है। सी सेट हर जॉ इन ए डिटरमाइंड मैनर। यहाँ पर सेट का कुछ और अर्थ है। सेट का मतलब बैठाना भी है। द सर्जन सेट हर ब्रोकन बोन। सेट में सनसेट भी आता है। तो मेरे कहने का मतलब ये है कि सेट का शाब्दिक अर्थ बहुत है। हम लोग जो सेट पढ़ रहे हैं, यहाँ पर सेट का शाब्दिक अर्थ है समुच्चय। ही इज सॉल्विंग द प्रॉब्लम ऑफ द चैप्टर सेट्स। तो सेट is an undefined term. We cannot define the word set. Whatever matter or whatever solutions we are seeing, that is the description of it, not a definition of it. Intuitively, a set is a collection. A set is a collection of well-defined and well-defined and well-distinguished objects of our perception. Like this, we can define a set. A set is a collection of well-defined and well-distinguished objects of our perception. Simply, we can say a set is a collection of well-defined objects. A set is a collection of well-defined objects. What is the meaning of well-defined? Well-defined. What is the meaning of this? The term well-defined implies a rule which helps one to identify whether a particular object belongs to the set or not. Or we can say, well-defined is defined as if we can definitely say whether a given or particular object belongs to the collection or not. If we can determine whether a particular object is a collection of that set or not, then we can say that is well defined. But what is the meaning of well distinguished objects? Well distinguished object means clearly defined or readily separated or distinct. This is the meaning of well distinguished objects. Clearly defined, clearly or readily separated or distinct objects. So a set is a collection of well defined and well distinct objects of our perception. Or we can say set is a collection of objects, but those objects should be well defined. A well defined collection of objects is called a set. A well defined collection of objects is called a set. The objects of a set are called members. The objects of a set are called members or elements. Members or elements. We denote sets by capital letters A, B, C, X, Y, Z, etc. We can represent a set by capital letters A, B, C, X, Y, Z. If A is an element of, if A is an element of a set A, suppose capital A, then we write A, this is an element belongs to A. Small a belongs to. The meaning of this symbol is belongs to. Small a belongs to A. Or if A is not an element of the set A, then we say A does not belong to capital A. The meaning of this symbol is does not belong. I think it is clear. If A does not belong to A, then we'll say like this. If A belongs to A, then we say like this. So symbolically we can represent whether the element or member is belonging to that set or not. How to describe or specify of a set? There are two ways or there are two methods of describing a set. First is roster or tabular tabular form, and second is set builder form or set builder notation. So there are two ways or two methods of describing a set. In the roster form, we list all the members of the set within braces. In roster form, we list all the members of the set within this braces and separate them by commas. For example, 1, 2, 3, 4, 5. These are natural numbers up to 5, and we have taken 5 elements, we have taken 5 members, and if you keep this one in braces with commas, then this form is roster form, tabular form. So in tabular form, in roster form, we list all the members of the set within braces and separate them by commas. But in set builder notation, we will write the information, the properties of the elements, For example, this can be written as all x's such that x is all x's such that x is a natural number and x is less than equal to 5, and you keep this information in bracket. This is known as set builder form or set builder notation. Roster form can be changed to set builder form, or set builder form can be converted to roster form. So there are two ways, there are two methods to represent a set. There are two methods or two ways to describe or specify the set, and the methods are roster or tabular form, and second one is set builder notation or set builder form. Now, types of sets. A set, first one is null set. Null set is also known as an empty set. It is also known as an empty set or void set. So what is a null set or an empty set or a void set? A set is said to be a null set or an empty set or a void set if it doesn't have any element. A null set is denoted by a letter phi. It is not to be confused with the Greek letter phi. In roster form, phi is also denoted as giving this two curling braces. So what is null set? A set is said to be a null set or an empty set or a void set if doesn't have any element. A null set is denoted by the symbol phi, and in roster form it can also be denoted as this curling braces. So what is an example of a null set? Suppose if I say the collection of students, those who are studying 24 hours a day. So there's no any student who can study 24 hours a day, then in that set there will be no element. So this is an example of null set. Now, finite set. And set consisting of a finite number of elements is said to be a finite set. Examples of finite set. First example, set of students in a class. In a class, how many students are there? We can count and we can find the number of elements. So here there are finite number of elements. So this set is a finite set. Set of, second example, set of even numbers of less than 50. Less than 50. If we say you collect even numbers less than 50 or even natural numbers less than 50, then we can find easily. So set of even numbers less than 50, you can say even natural numbers, that will be better. Even natural numbers less than 50, that is finite set. What is an infinite set? A set having an infinite number of elements, that is called an infinite set. Set of all rational numbers set of all rational numbers between 1 and 2. In between 1 and 2 there are infinite rational numbers. In between 1 and 2 we will find infinite rational numbers. So this set is an infinite set. Set of all natural numbers. Set of all natural numbers is also an infinite set. What is singleton set? A set consisting of only one element, that is called singleton set. A set consisting of only one element, that is called a singleton set. For example, this is a set containing one element, that is 0. So this is a singleton set because this set consists of only one element, that is 0. Remember that it is different from null set because in null set there is no element present there, but here there is only one element, that is 0. So singleton set is a set consisting of only one element. I think it is clear. If I say in set builder notation, all x's such that x is an even prime, there is only one even prime number and that number is 2. So in this set builder notation, if you convert this one to roster form, then we will write only 2. So this is a singleton set. Now equal sets. Two sets A and B are said to be equal if for every x belong to A, x belongs to B and vice versa. Suppose A is a set having only two elements, 1 and 2, and B is also a set having two elements, 1 and 2. Here elements are same, number of elements are also same, so A and B are equal sets. However, two sets A and B are said to be equivalent if the number of elements A is equal to the number of elements of B. A is equal to 1, 3 and B is equal to, suppose, 2, 4. Here number of elements in A is 2 and number of elements in B is also 2, no matter the elements are different. So here A and B are equivalent, not equal. But in this two sets, we can say A and B are equal sets. But here A and B are equivalent sets. What subsets? A set A is said to be a subset of B if every element of A is also an element of B. Suppose A is equal to 1, 3 and B is equal to 1, 3, 5, 7, 9, 11. Here there are two sets. Every element of A is also present in B. If every element of a set A is present in B, in the set B, then we say that A is a subset of B. I think it is clear. Now, universal set. The superset of each of the given sets is the universal set. Thus, a set that contains all the sets in a given context, that is a set of which all the given sets are subsets, that is called universal set. Universal set consists of all the sets present in that context, and it is denoted by the capital letter U. And what is power set? The family of all subsets of a given set is known as power set. For example, A is equal to 1, 3, 5. This is a set. So null set is also a subset of A. A set containing 1 is also a subset of A. The set containing the element 3 is also a subset of A. The element containing 5 is also a subset of A. The set containing the elements 1 and 3 is also a subset of A. The set containing 1 and 5 is also a subset of A. The element containing 3, 5 also a subset of A, and the set containing 1, 3, 5 is also a subset of A. If you collect all these subsets in two braces, then this is known as power set of A. Thank you.